Okay, describing a little bit further why covariance is a little bit difficult for us to work with or kind of impractical for us to communicate our findings in this regard. So if we have variance, you can imagine if we have measuring mice and one feature, mouse squared is not super confusing. You have 10 mice squared. That's okay. It's 100 mice. A lot of mice, but it's possible to get there. Problem is when we have covariance, we have unit x times unit y. So if we have mice in one, chameleon in another, we have mouse chameleon or a chimeleon. And if you didn't know that was the name of a mouse chameleon, a chimeleon. Um, and so one of those things, it's, obviously that's a little bit confusing. He's very cute, he's adorable, but a little bit confusing in terms of communication. Like, how are we going to communicate that properly if, well, it doesn't really exist? It's not a real unit of measurement. Chameleons are not easily understood, not really a unit of measurement. So we tend not to use covariance as the standard measure of our relationship, because it's also not comparable to other data sets. Even if you have a good sense of what 10 chameleons are, you have a hard time comparing that to banana oranges or something along those lines, right? We have a really hard time. We would have a very hard time, especially with the different scales, making comparisons between different values. So we really don't get a sense of how good, how strong this is, because we need to do this comparison throughout our whole data set. We can't be thinking about, okay, well, this was really strong, this was really weak, the chameleons were sort of strong, the banana oranges were very weak. It just becomes very very confusing and a lot more cumbersome than we would really want, especially when we're communicating our results.